Okay, geometry class, we're going to review for a test that's going to be tomorrow, unless there's lots of questions tomorrow, but I don't think it's going to be a hard test. All right, so let's start by taking notes. Mrs. Roberts will give you the note sheet and you can listen and take notes at the same time. What is the geometric mean? The geometric mean between two numbers is the ratio such that the number over x equals x over the other number. So then you would set the two cross products, you would set the cross products equal to each other. So then we would know x squared is equal to a times b. And then x is equal to the square root of ab. So part of the test is you're going to have to simplify radicals. So let's do an example. The geometric mean between 4 and 12. So it'll be 4 over x equals x over 12. And that's going to give me x squared, as I multiply that diagonal, is equal to 48. And then now I need to take the square root of both sides. Okay, so when I take the square root of both sides, I get x is equal to, and I have to ask myself, what is a perfect square that goes into 48? And you should have all these notes, the perfect square notes, with you. So this is going to be 16 times 3. I like to underline my perfect square. Out pops the 4. 4 squared is 3. Okay, pause the video right now and try the other one on your own and see if you can get the right answer. Six squared is 2. I did a little bit backwards there, but 6 squared is 2. Okay, pause the video if you need to practice that. Make sure you write that down. But this, take a marker, make sure you put a square over that. That's what it's asking you for, the geometric mean. So we're going to use the geometric mean now in these formulas about the altitude and the leg. So what we know is that the altitude is the geometric mean between parts of the hypotenuse. Now it has to be of a right triangle. It has to be the altitude drawn to the hypotenuse of a right triangle so that it breaks it up into parts. So we're needing to solve for x and for y. But first let's put the formulas down. The formula is this. The altitude is the geometric mean. So that's the part that gets repeated between the two parts of the hypotenuse. Part 1 and part 2 of the hypotenuse. Part 1, part 2, the altitude. Okay, we'll go about solving for that in a minute. The next piece is that the leg is the geometric mean. So there's two legs, so we need to have two formulas, and it's important to understand that it is between the part that's touching the leg. So if this is leg 1 right here, then the part of the hypotenuse that we're talking about, it has to be touching that leg to the entire hypotenuse. Okay, so that's that one. Okay, so then the other leg. So if we have leg 2 is the geometric mean between part 2, because if this is leg 2, the part that it's touching is this part 2 to the entire hypotenuse again. Okay, so now let's do our examples. Okay, you can pause the video and do it on your own first if you want. Okay, so the first one, the altitude. So that's the y value. So when you see these problems, the first thing you're going to ask yourself is, what part of the triangle am I looking for? And what do I have? Okay, so I'm looking for y this time, and that's the geometric mean. So that's the part that needs to repeat. A lot of times they might give you a number here, and then you're going to put a number there. Okay, between the two parts of the hypotenuse, 6 and 24. We have to have at least two numbers in order for us to get an answer. We're going to set our cross products equal. So y times y is y squared. is equal to 6 times 24. 6 times 24 is 24, 12, 144. So then we take the square root of both sides, and we have, whoops, y squared equals 144. Y then would equal 12. I don't know why I put it twice. Okay, so 6 times 24. All right, so that's the altitude being the geometric mean. The other part is if the leg is the geometric mean. Now we only need this leg. We don't need both of them this time. But we could also think about Pythagorean's theorem if we had another one of these pieces. Okay, but the leg is the geometric mean. So that's the part that repeats. So I'm going to let x, it repeats right there, to the part that's touching the leg. So this part's touching the leg, so that's 6 to the entire length, which is 30. So now we're going to set our cross products equal. By the way, you could pause the video and do it yourself first. X squared is equal to 6 times 30 equals 180. Now to get rid of that x squared, I'm going to take the square root of both sides. And I get x equals, now we need to find a perfect square that goes into 180. Well, I know, so here's how I'm going to break it down. 9 goes into it 20 times, but 20 can be broken into 4 times 5. Okay, the reason why I do this is this helps me. The square root of 9 is 3, the square root of 4 is 2, or this is really 36, right? And 36 is a perfect square. And the square root of 36, out pops the 6. Square root of 5. Okay? All right. Next one. Pythagorean's theorem. Pythagorean's theorem, there's really two kinds of problems. Pythagorean's theorem, we have to remember first of all that we've got a squared plus b squared equals c squared. And what's really important about that is that c must be the hypotenuse of a right triangle. Okay, so let's do the two cases. Case 1. Okay, case 1 is when I'm looking for the hypotenuse. Okay, so I'm going to pick two values. Let's pick, I don't know, 8 and 5. Okay, so if I know I have a right triangle and I'm looking for that third side where I have 8 and 5 as the two legs and x is my hypotenuse. So I'm going to use Pythagorean's theorem. A squared plus b squared equals c squared. The only thing that matters, let's make this an x, is the fact that my c is x in this case. So I have to make sure it's over here. It's not, x is not always on this side. So let's solve it. 64 plus 25 equals x squared. These are on the same side, so I do what it says. And so I get 89 is equal to x squared. Got to get rid of that squared, so I'm going to take the square root of both sides. And that's my answer, because it can't get any smaller than that. Okay, so let's try one more case. This is case 2. Case 2. Okay, this time we're missing a leg. This is a 6. I know my 6s are sometimes confusing, but that's a 6. So I'm going to fill this in with Pythagorean's theorem again. A squared plus b squared, which is my 6, should have chosen a different number, is equal to 14 squared. Okay, so these are on opposite. I'm going to go ahead and find the values for the 6 squared. A squared plus 36 is equal to 196. Okay, 196. So now these are on opposite sides of the equal sign, so I'm going to do the opposite operation. I'm going to subtract 36 from both sides. And I get a squared equals to 160. And now I need to solve for a. So I am going to take the square root of both sides. A is equal to, now 16 and 10 are factors of 160. 16 is a perfect square. So the square root of 16, out pops the 4. And I get 4 square roots of 10. Make sure you write these notes down because you can use them on the test tomorrow. Okay, the last part, special triangles. Okay, so in this triangle, this is a 30, 60, 90 triangle. Remember that this is the short side, and so this is x. The hypotenuse is 2x, and the long leg is x squared roots of 3. I'm going to label this as long leg and short leg. So if you're given the hypotenuse and you want to find the short leg, okay, so we're finding, because the whole purpose of finding the short leg is because it's the key point to find all of those. Okay, so I'm going to take to find the short leg, I take the hypotenuse and divide it by 2. Okay, if I'm given the long leg, I still need to find the short leg first. Given the long leg, the short leg is equal to the long leg divided by square root of 3. Okay, so you have to remember each of those things. So this is if I'm given the short leg. Given the short leg, then I can use all of those relationships. Now over here, if I'm given 45, and this is if I'm given the legs, because in a 45, 45, 90 triangle, we know these two sides are the same, and it's x, x, and x square roots of 2. So my leg is equal to the hypotenuse divided by square root of 2. Okay, so we're going to do some examples. So you're going to flip your paper over. I'm going to do it fast. I'm running out of time. All right, so we're going to do, if this is a 30, 60, 90, I'm going to do 2 cases. If this is 5, then how do I find the rest of the pieces? Well, oops, I got to switch this around. Well, not really, but I'm going to. 60, 30. There we go. This is my short leg. So I know the relationship between the pieces. This better be 5 square roots of 3, because it's times it's by square root of 3, and this is twice as much, so this is 10. What happens if I gave you, we'll do all 3 cases. If I gave you, this as being 7, and I want to find the other 2 pieces. Okay, so since this is the long leg, I need to find the short leg. So remember, I take the long leg divided by square root of 3. Now, this is an issue because we can't have square root of 3 in the denominator. Okay, so I need to multiply it by square root of 3. So I get 7 square roots of 3 all over 3. The hypotenuse is twice as much as this, so it becomes 14 square roots of 3 all over 3. Let's do the last case. Again, a 30, 60, 90. And what happens if this is, we'll make it nice and even, 12. If that's 12, we know it's the hypotenuse divided by 2. So this is 6, and this is 6 square roots of 3. Now there are only 2 cases for, you can pause that at any time because I'm going to go fast. 2 cases for 45, 90. is if I gave a leg, so if this is 7, the other side's got to be 7, and this is going to be 7 square roots of 2. Actually, we'll do 3 cases. What happens if I give you this leg is 5 square roots of 2? And a 45. So this one's going to be 5 square roots of 2 as well. But this is going to be 5 square roots of 2 times square roots of 2. And remember, if they have the same radical right here, you can same kind of radical, you can multiply them, and I get 5 square roots of 4. Or in this case, the same number times the same number, out pops the number. So I get 5 times 2, which is 10. Okay. And then the third case is what happens if what I'm giving you in a 45, 45, 90, and if I give you 10 as my hypotenuse. So you take the hypotenuse and divide it by square root of 2. In our case, it's 10 divided by square root of 2. That's my answer, except can't have square root of 2 in the bottom. So multiply it by 10 square roots of 2, and I get 10 square roots of 2 all over 2. I can reduce this part. 10 divided by 2 is 5 square roots of 2. Oh my goodness, I just did the same problem. And the lights just went out. And there we're back. Okay. Make sure you write all these notes down, and I might post a game too. So have a good day.